Hello everyone, my name is Eric Crowell, and on behalf of Correlsense and Emulex, I'd like to welcome you to today's presentation introducing some best practice basics that will help your apps safely make the jump from the physical to the virtual environment. Before we get started, we have some housekeeping I'd like to go through. Please note that due to the large number of attendees today, all lines will be muted, but we still want to hear from you and answer your questions. At any time, you can use the GoToMeeting widget, specifically sending questions to staff, to submit your questions to us. We'll get on them as soon as we see them. Speaking today will be myself, Eric Crowell. I'm the product manager of the One Command Vision software from Emulex, and later today we'll hear from Oren Elias, the EVP of Strategy and Business Development for Correlsense. Finally, also remember that at the end, we'll be drawing a winner from the attendees of today's presentation. One winner will get themselves an Apple TV. So with that out of the way, let's get started. Today we're going to focus on P2V migrations. We're going to talk about application and I/O performance and their role in P2V planning. We'll review some practices that ensure performance levels and peace of mind are maintained during the P2V transition. And finally, we'll take a look at some tools available to help. And as always, we'll allow a lot of time at the end for your questions and answers. So with that, let's jump right in and talk about application and I/O performance and their relevance to P2V. Here's what the experts are saying. Emulex and Correlsense know that application performance is often critically linked to business performance. We know application performance is dependent on a number of important factors, but often overlooked is the important role of I/O. Gartner says that 50% or more of application wait time is attributed to I/O. Taking that a step further, IDC says that each app has its own unique I/O fingerprint, and that fingerprint should be factored into the data center cost structure while planning. When considering migration of applications from physical to virtual environments, it's critical to measure application response time and application transaction throughput. By understanding these key performance indicators, administrators can begin to map out the expectations they have for the virtual environments they're migrating to. That's simple enough to understand. Let's take a look at the growing complexity of IT to take it a step further. Measuring good performance today and setting expectations is the mantra. But what does good mean? That's getting harder than ever to answer in today's complex IT infrastructure. IT teams are already wrestling with the growing diversity of applications and the increased rollout of new solutions. Applications themselves are more complex, often depending on multiple tiers to deliver a single service or product to internal or external customers. And virtualization is adding new layers into the network and I/O stacks that are blurring the hardware line. And the path to storage has become more diverse and complex with the introduction of SSD block caching, converged networks, and virtualized storage. It's hard to get a picture of what good performance means. Let's talk about the end-to-end challenges. The best approach is to measure performance end-to-end, from the user's perspective, from the application's perspective. And this is in line with evolving service-oriented architectures. But it's complicated, and administrators are facing more pressure than ever to reduce time to deploy, increase the number of apps supported, and extend the infrastructure performance. The challenge is how to manage application availability and performance with tools designed for legacy infrastructures or individual device management. You need a more holistic view. But there's more to it when it comes to P2V. There's a lot of fear out there surrounding potential loss of control. It's easy when you own the infrastructure, but with the virtualized environment, it's all about sharing. What if application performance before migration, what if application performance migration doesn't match application performance afterwards? There may be no way to go back to the hardware that you had before. There's a lot of worries, and the best practices that we'll review later today are really designed to address these latent fears by relying on empirical measures of performance to set expectation. So why should application owners care about storage, and vice versa? Well, traditionally application performance is centered on the user or network performance. Recently, tools have been introduced that reach deeper inside the application, providing a wider picture of where software and hardware interactions are slowing down. But as we discussed, often missed is the importance of storage performance. We've seen the experts pointing to I/O performance as a major factor in how large an application can scale and how fast an application can perform. Likely one factor driving that is the dramatic increase in CPU, memory, and in general server performance. This hardware is getting faster, putting more and more emphasis on the I/O feeding it. Another is the increased reliance on data analytics to provide sophisticated application benefits and deep DB queries that even when well written move lots of data. Also important is the role that storage can play in the resolution of problems in the data center. Many times when an application slowdown or brownout occurs, there are a lot of finger pointing. Which domain does the problem lie in, storage or application? Is it a bad query, or is it a peak storage system causing applications to wait? Are there too many embedded objects, or is the data stored on storage that is just too slow? These are just a few of the questions that can be quickly answered when you include storage I/O as part of a holistic approach to application performance monitoring. So let's talk a little bit about best practices. We've covered the basics of why apps and I/O performance are important to migration and how tools out there don't cover this stuff and leave administrators with lots of anxiety. Let's look at some best practices targeted at assuring these migrations go successfully. Our advice is don't start without a clear plan. Identify the application and storage dependencies. Then prioritize the order in which those complex applications are virtualized. For example, making sure you understand the storage I/O performance required for each application tier and also the application tier performance required for the overall application performance. The first step should be to baseline real-world end-to-end performance from each part, network, application, and storage. Next, those baselines can be used to enforce robust performance SLAs that encapsulate response time, throughput, and transaction performance. And finally, using those SLAs, and some tools we'll show you later, you can automate the monitoring. It's a little like taking a black box approach to application performance. Assuming that we provide the same input performance characteristics, we should expect the same output post-migration. So the question is, are tools in place today that help you monitor I/O performance? Here we've outlined a simple topology hosting a critical internal customer application or customer application. For each piece in the puzzle, there are already tools in use today. These tools are focused on CPU cycles, network connectivity, SAN utilization capacity, and device health. All important functions, but none are focused on the end-to-end performance and health of the I/O and application data that's flowing over this path. So this P2V checklist is pretty important to assure application and service levels. To help crystallize this a little further, here we have an example of how unintended spindle contention can cause hosts and applications to wait. In this example, we have a shared file system being deployed on high-performance I/O infrastructure. This is something we see all the time as customers grow their virtualized environment without monitoring application performance. As more and more hosts are added to the infrastructure, we see that the shared infrastructure is bottlenecking on unintended spindle contention. What administrators need are tools that catch these types of problems before bigger and more expensive issues occur. So with that, I'll hand it over to Oren Elias, EVP of Strategy and Business Development at Correlsense, and Oren will introduce you to some of the tools we have in the field today to help solve these types of problems.
Hi, everyone. Thank you, Eric, for the introduction. Can we switch to the next slide, please? Great. So we've put together what we call the top 5 layers of user frustration. And essentially, I think users tend to get more and more frustrated as time goes by. Obviously, as the application is more important, people have a tendency to be to have less tolerance. but over time, these things can accumulate. In this case, it goes from user just noticing the slowness and kind of working around it. We tend to say that the user is often the most adaptive part of the entire IT ecosystem. But users often start to lose patience pretty quickly. What we've seen, especially in physical to virtual projects and migrations, is that the user's perception of user experience really becomes their perception of the whole virtualization project. We've seen at Correlsense projects where people spent a lot of money and a lot of time to build a virtualized data center, whether it's just a virtualized data center or ranging up to a private cloud. But the first thing that the user will actually experience and notice is that second when the application migrates from the physical world to the virtual world. And people tend to be nostalgic about their applications. We often hear the users saying, it was better on the old system, just bring us back to the old system. And if you think about it, a P2V migration really doesn't improve anything from the perspective of the user. The primary driver is to reduce cost, not necessarily to increase response times. But because of that, being able to prove that response times didn't degrade, even if they didn't improve, becomes a critical part of the physical to virtual migration. One example that we've seen in the past with a large financial customer is an application that actually did degrade, and the need was then to migrate it back after about 2 weeks of user frustration, migrate it back to the physical world, retest it, migrate all the information back from the new system to the old system, and essentially a full delay of nearly 5 months of the entire project, just because of inadequate ability to predict and manage the user response times and the user experience in these first critical 2 weeks. So we believe that these 2 weeks are actually what enables you, can you click please? What enables you to be proactive before you move from step 1 to step 5. So the idea is that within these 2 weeks, being proactive by understanding the response times will enable you to easily manage and tweak and tune the system when the user is actually at step 1 before the user is completely on fire on step 5. Next slide, please. So I wanted to take this chance to talk a little bit about tools that we believe that can help. We'll use our tools as an example, but really I think the idea is to talk in a general basis about how tools can help mitigate the risks of the physical to virtual migration. I think the first thing that we understood when we started working with Emulex was why really as an application person we should care about physical storage or virtual storage. I come from an applications background, and to me storage was always just something that you plug in, you request quota, and you build your application. But the reality today is that storage is no longer one size fits all. And based on the characteristics of the application, the correct tuning and configuration of the storage segment that you will get is based, which directly ties into the kind of performance you're going to get with your application. A very simple example is an application that does media streaming will require different characteristics from the storage layer than an application that primarily does I/O writes, for example, an application that does extensive logging. And you may have two very different applications receiving different response times and different performance from the exact same storage layer just because it wasn't adapted to what the application was doing. So to me, as an applications person, it was fascinating to understand that there's now a need to take that into consideration when architecting a system into production, and it drives application people to have a better understanding of what is storage, what are the characteristics of storage, and obviously how do you monitor storage in production. So no longer a separate silo, but definitely a inherent part of the application. Next slide, please. So again, the understanding of storage and how it ties into the application becomes key in the ability to rapidly isolate various performance issues. A good example that we've encountered is a financial portal, an online system of one of our customers that was experiencing severe performance issues, and we were kind of brought in to help diagnose what was going on. And the phenomena was somewhat odd. They were having spikes of workload at the end of the business day, end of the trading day, which is normal, but the system would hang for about 5 to 10 minutes until a full restart of the entire cluster of servers was performed. And then the issue would kind of just go away and reappear pretty much the same time the day after. And they were looking at it individually. The only thing that seemed odd was that there was an increased workload going on within the storage of the database. What we typically see in performance issues, especially when migrating into a virtual environment, is that issues start to cascade. The example of too much latency and too many bottlenecks on the storage layer quickly propagates into the application on the virtual layer and quickly creates bottlenecks to the point where users can no longer use the system. You often find phenomena in other places in the application that actually originated further down in the database and in the storage. In that specific example, we saw the workloads actually spiking up to 100% of CPU on the database and also clogging up all of the I/O writes and reads on the database, and as a result of that, the database storage layer. So the problem was very evident, but the next step that was asked was, where does this actually come from? Is this pulling information? Is this trade information? So there was the immediate need to answer the question of what actions that users are doing is driving that 90 to 100% utilization of all these resources. We were able to quickly tie and put context around the workload to show that was one specific graph of one specific ticker that was refreshing every few seconds, that wasn't creating an issue when there was 100 or 200 users, but when there were several thousands of users doing this concurrently, very frequently it created a bottleneck. This was easily resolved by putting some caching in place, but again, most of the time was spent on trying to figure out what was actually consuming most of the resource. So this is a classic example where tying the end-to-end would have been able to actually gave the full solution, and the resolution, the solving of this issue was very, very quick. It was up and running within an hour, and the workload went down from approximately 90% to an average of about 10 to 12%. Next slide, please. So what we've done together with Emulex is actually combined our ability to view every single transaction coming from the end user, hopping between all the various tiers, together with one command vision and its ability to actually provide very granular and detailed metrics around the storage tier. We've seen a growing trend within IT operations of becoming more application-centric. Looking back a few years, it seems like development teams have been increasingly pulled into providing support for applications in production. And recently, organizations have started to charter IT operations teams with the need to move from just managing availability to actually owning performance. I think everyone has now realized that if a server is 100% up, but we're getting 20-second average response times, this is not really meeting our SLA. So SLAs are moving from pure uptime percentages of 99.99 to the need to actually manage SLAs from a response time perspective. As a result, operations teams need to have a much more complete view when managing applications in production. We recently spent some time with a prospect and had a very large meeting with both operations people and development people involved. And you could see the dynamic where development people were saying, we know that 100% of our issues are in the code. Why would we care about anything outside of the application tier? On the other hand, the infrastructure and operations people were saying, we only escalate issues that are in the code. It's our job to actually look at the entire infrastructure, and for us it's very interesting to tie in the web tier, the service tier, the database, and very important to tie in the storage as a main factor that now affects application behavior. And again, this is all accelerated when moving into a virtual environment. So parts will be virtualized, parts will be physical. Typically, the database would remain on a physical tier, and the storage ties into each one of these layers and plays a critical role in response times and application availability. Next slide, please. So we wanted to take this chance to present a live demonstration of the two tools working together in tandem, tying the information and showing how we can tie both ends, starting from one end, which is the storage, and moving up to understand what the context of the request was, and also viewing degradations on the user experience and having some understanding of what was the root cause down to the storage level. We believe this is a unique approach, and I today view risk factor number one in P2V to be performance, solely because of the reason I mentioned earlier, that this is the first measurable outcome of the entire virtualization project, and this is probably the only perceived benefit that the users will actually view from the virtualization project would be the response time and the user experience. So with that, I'll hand it over to Amir Gabrieli, who will show a few examples of how viewing both the storage and the application layer can be very beneficial in terms of minimizing the risks when doing a virtualization migration in terms of performance.
Thank you very much, Oren. Thank you, Eric. So we prepared this demo use case, and in this demo use case, we have a CRM application that is being migrated from a physical environment to a virtual environment. Now, obviously, the CRM application owner has some concerns about moving to a virtual environment. He really likes the over-provisioning of the physical environment. And it was decided that SharePath and One Command Vision will monitor the migration process. Will monitor the CRM application through the migration process. So the migration takes place on May 28th, and what you see here is the CRM application KPIs 2 hours after the migration and after end users are working with the system. Okay, what you see here is the SharePath application dashboard. Currently, SharePath is monitoring a single application, the CRM. 2 hours after the migration, the CRM application was accessed 5,000 times by real end users. The average response time is 2 seconds, and the SLA compliance percentage is 92%. Now that's not really good number, so the application owner is a bit concerned. The average response time is almost 2 seconds, which is relatively slow, and the SLA compliance is 92%, only 2 hours after the migration. And when we drill down to the service level of the CRM, it turns out that some of the services that the CRM offer end users are actually in the yellow, have yellow alert, and some of them have red alerts, with an average response time of 5 seconds. Average response time of 5 seconds for the end users. So the migration failed. Okay, the CRM application is not performing, service level are being violated, and we have one of two options. One option is to migrate back to the physical environment, and the second option is to use SharePath and One Command Vision to figure out why the CRM application is performing poorly across the virtual environment. And the decision was to further investigate and figure out why the CRM application is slow. So in order to do that, we first need to know where most of the time is spent, right? We have slow services, and we want to know where most of the time is spent across the entire technology stack from the end user to the spindle. We choose just one of the slow-performing services, like the user services that you see here, with an average response time of 3.5 seconds. It's a very slow service, and the average response time that you see here is based on 400 activations by real end users. Okay, so we take the service, and we create a performance model to understand where most of the time is spent. So zooming into the user's service of the CRM application and creating a performance analysis based on the data that was collected so far, the user service was accessed or being approached 400 times by the end users with an average response time of 3.5 seconds, a very slow service. And when we analyze where most of the time is spent, it's quite obvious to see that 84% of the time, out of an average response time of 3.5 seconds, are spent on the database. So in average, 2.8 seconds are spent on the database. SharePath was already able to isolate the database as a problematic component of this virtual architecture. And when we drill down into the SQLs, we can see the different SQLs and how they impact the response time. It turns out that the slow SQLs are actually the SQLs that need direct access to the data that is stored on the storage. Now, a different view that shows more or less the same information is the application topology view. Okay, so what we see here is the application topology, and the CRM application is relatively a simple application with a single server and a single database. And you can see that 2 hours after the migration, the average latency from the application to the database is 40 milliseconds for SQL. Now, 40 seconds for an average latency of 40 seconds to an SQL is relatively slow. We want SQL to be executed in about 10 milliseconds in average. So the database is slow. Okay, now there are two options. One is the storage. Second, it's the database is misconfigured. We'll start with examining the first option and see how the storage performs to the application. So from the topology map, we choose the database node, and we ask Sherpas to show us the IO stat of the storage to figure out how the storage performs to the application. That basically creates or jump or move us to one command vision where we can see the different IO stats of the storage to the application, and I'll let my colleague Bino to explain what we're seeing here.
Thank you, Amir. As you can see in this chart, the top chart represents the total IOs from this particular server, and in the bottom chart we see different storage LANs used by the application. And as you can see, the LAN 1, the latency of LAN 1 is spiking when the application performance is degrading. And clearly that is causing the application's performance to go down, and the I/O operations per second is also going down when the LAN 1 latency is increasing. At this point, there are two options data center administrator can do. Either throw more money at the storage or look at the I/O profile of the application and optimize the current storage infrastructure. In this case, what we did was we analyzed the storage I/O profile and decided to move the application or storage vMotion this application to a different LAN. So we created a LAN 3 with a higher RAID level, and we motioned the application to that storage.
Okay, so back to Sherpa. So we made this change. It took us 1 day, but after the 1 day, we basically did a storage vMotion, mapping the application to a faster storage, and we want to see how that impacts the application. Now, before I'm showing you the new result, I just want to emphasize that from incident to a decision to map to a new storage, it took us less than 20 minutes. And that's amazing with a solution like Sherpa. From incident to decision, any problem across the entire topology stack, less than 20 or 30 minutes. So it took 1 day, okay? It took 1 day, and now we're on May 29. Again, 2 hours after 2 hours after we started the application on this new storage and opened the application to end-user traffic, May 29, again, about 5,000 calls to the application. Average response time is 1.3 seconds, which is 700 milliseconds faster than with a slow storage. So we already know that there's a significant improvement. But what's amazing here is that the SLA compliance now is 100%. All the transactions, even at the service level, are 100% meeting the SLA, and the application is okay. The application owner is now satisfied with the with moving to the virtual environment. Another thing that we can do, we can kind of, if we want to better understand the impact of the change on the application performance, we can do what we call a change analysis, comparing the application performance on the new storage with the application performance on the old storage. So what I'm doing here is a comparison, comparing it with the first attempt and the slow storage. Oh, sorry, I just gave the wrong dates. Sorry for that. Until 28. Right. Okay, so now we have a side-by-side comparison of the application today with the fast storage that had the average response time of 1.3 seconds, with the application on the slow storage with an average response time of 1.8 seconds. So you can see that on the application level, but we can also see that on the different component level, and see how significant was the change on the database server level. Moving to the fast storage, reduced the average response time or time spent on the database for each transaction in almost 50 milliseconds, which is a lot for a single transaction. These are the quick change analyses that can help us quantify the impact of changes as we do the changes. And going back to the topology map, same topology, same application, different time frame, and now the latency between the application and the database is 12 milliseconds, which makes sense for a typical online application to have an average SQL latency of about 10 milliseconds. And finally, just to verify that the storage indeed is working better, again, we can jump into one-for-one vision, and I'll let Dino explain what we're seeing here now.
So here in the bottom chart, you can clearly see that the parameter, the axis changed from 700 milliseconds to 180 milliseconds, and the latency of the storage LAN now is within 20 millisecond range, and it's a very good performance we are getting from the storage layer. And the IOPS are also getting very good performance, and we can see that issue is resolved from the storage side.
Okay, so that was the demo. Thank you very much.
Okay, folks, thanks for bearing with us as we switched over. So let's just take a final second to sort of wrap up. As we've talked about, the combined advantages of these two products together really give you the ability to monitor transactions from the client, end users, through all of the tiers of the application and back out to the storage. And being able to drill down into that transaction data to understand the storage impacts or lack thereof on application performance, and sort of establish these proactive SLAs that we just saw in action that help you make it from your physical to virtual environment intact and ensure user satisfaction and performance. So with that, we'd like to thank you and encourage you to go off and get more information about the respective products. You can visit us at emulex.com/vision or right off to the Correlsense.com site to get further details. Just after this meeting, we'll draw a name from the attendees list for our Apple TV giveaway. So please make sure you take a look for an email from us to let you know if you're a winner. Thanks again, and I'll hand it over to Richard.
Thanks, Eric. Hi, my name is Richard Delay. I'm with Correlsense. I'm the marketing manager. We'll be sharing the presentation on SlideShare, and we'll make sure that you will have a chance to take a look at that. So we'll wrap up the webinar at this point. So I just wanted to say thank you to all the presenters today, and thank you to all of you who have attended. And so we wish you a good day. Thank you.